morning everyone. I am Dr. I.Munavar, Assistant Professor ECE, Acharya Institute of Technology, Bangalore. Today we will discuss how to perform Common Source Amplifier as per VTU syllabus. So, as per VTU syllabus, ninth experiment, construct the schematic of Common Source Amplifier with PMOS as a current mirror load and find the transient response and AC response. Measure unit gain bandwidth, amplification factor by varying transistor geometries. Study the impact of variations in width to unit gain bandwidth. So, here we are going to use PMOS current mirror as a load to common source amplifier. We are going to find out transient response and AC response. Also, we are going to measure unit gain bandwidth and we are varying the width of the PMOS to see the impact of unit gain bandwidth. So, first we will perform the pre-layout simulation, then part B is post-layout simulation. I will first do the pre-layout simulation in this tutorial. So, first we have to go to File. After invoking your virtuoso, go to File, New, Library. So, here I am giving VLSI, Design and Testing, Lab. So, 180 nanometer I am going to perform. So, 180, attach the existing library, then click OK. Now, here select GPTK 180, click OK. If you already created library in 180 nanometer, then no need to create it again. Then go to File, New, Cell View. So, here select your library. VLSI Lab 180 nanometer. Under this, type CS amplifier, common source amplifier. Click OK. Now, here as you know, first press I for instances. Here I want GPTK 180 nanometer, PMOS, press tab, then click hide. This is PMOS. I need 2 PMOS and 1 NMOS. Now, we have to flip it horizontally. No need, don't rotate it. If you are rotating, your source will come down. So, no need to do that. Just flip it. To flip this, select this one, go here and flip horizontal. Then click it again. Now, you have 2 PMOS, 1 NMOS connected through wire. Shortcut is W. Now, we want VDD and ground, press I. VDD and ground will be available in analog lib. And for substrate, you can use same VDD or to rotate. Then we want ground, G and D. Again for NMOS substrate, you can use the same ground. Now, we want output pin, shortcut is P. V out, connect it here. To move it, shortcut is M, select it and move it. And I want input pins, shortcut is P. I want V bias also. V in, V bias. Our schematic is done. Check and save. Now convert it as a symbol. Create cell view, from cell view, symbol. Now can delete these things. Shortcut is delete. Here rename it as, just double click, rename it as CS amplifier. Check and save. Close it. Now we want to create a test circuit. Just click it and common source amplifier test. Now instantiate your symbol. Shortcut I. Go to your library, VLSI DT lab. Here your symbol is common source amplifier. Now we want to connect the voltage sources. So first we will connect VDD. Go to analog list, VDC 3.3 volt. We want ground. VDD. This is your schematic. Now we want V bias. That is actually current source. For reference, you can follow this. So VDD is 3.3 volt, V bias is 100 microampere current source, V sign is AC magnitude 1, amplitude 10. You can follow this. Now we want I sign. I sign 100 microampere, press tab. This is I sign. It required ground. Shortcut is C to copy. Then V bias. Then we want V bias N. and V sign. To move, shortcut is M. This is VDC. Variable is V bias N. It required ground and it required one V sign, I, V sign, and here AC magnitude is 1, amplitude is 10 micro, frequency is 10 kilo, and it required one resistor of 100 micro ohm, and this goes to VE. We'll move it little bit. To move, shortcut is M. To pick, F. Now we have all the required voltage sources, and we need one capacitor, 500 femto. Instance I, analog lead, capacitor, 500 femto. So this capacitor is 500 femto. Shortcut is Q to change the properties. Everything is set. Check and save. No errors. No launch ADEL. First thing, we are using variables. So select the variable from cell view. This V bias is 592 millivolts, and we have to do transient response 100 nano. Then we have to measure AC response, frequency varying from 10 to 10 giga, logarithmic scale, log. Then we have to measure DC response, varies from 0 to 10. Okay, now we have to select input and output. Input, press escape. Then set. Now select your setup library. It's 180 nanometer, so 90 nanometer you can delete. Okay, now run it. This transient response is not getting right, so we will change it to 100 milli. Okay, now if you want you can move it to separate window. You can see this is your transient response. To get more clear output, we can reduce the time size. Say 1 milli. Now you can see this should be inverted. V output should be inverted version of V input. Okay, now to measure this AC response, go to ADL window, result, direct plot, AC magnitude and phase. Now you have to go to schematic and click the output. Okay. Now it will reflect here. Now you can see that phase and magnitude is here. You take it to new window. So this is your 20 decibel guide. Select it. Now find out 0 dB. This is your 0 dB. To measure unit gain bandwidth, press horizontal line, bring it to 0 dB. So this 171 megahertz is your unit gain bandwidth. Okay. So impact on unit gain bandwidth depends upon width of the PMOS. So just I am changing here the width of the PMOS. Say I am going to use 8.85. Okay, and this is also 8.85. We are trying to see the impact on unit gain bandwidth that depends upon the width of the PMOS. Control E to get out of the schematic. Now check and save. Now I will run it. radial window, results, direct plot, AC magnitude and gain, click your output, escape, come back to your, get it in your new window. Now check it, unit gain bandwidth. It is reduced. Okay, 135. I think earlier it's 171. I think, I don't know. So it is the impact on unit gain bandwidth depends upon the width of the PMOS. This is pre-layout simulation. To check what all the things you have done, go to tools, library manager, here this is my library. I have done common source amplifier, schematic, I created symbol, I created test circuit, in that test circuit I created schematic. Now I can save this for future reference. This is my output. You can close this. Now if you see here, you have output as well. I hope you understand how to perform common source amplifier and measure the transient response, AC response and unit gain bandwidth. In next video we will do the post layout simulation and verify the same.